Today we're going to talk about derivatives of some common functions. Very often we use these functions and we need to know what derivatives are, but normally we don't need to know derivation for these formulas. So here we're just going to state the facts, okay? And the functions we're going to look at is sine, cosine, exponential function like a to the power of t, natural logarithm. All right, let's get started. First function is sine. Derivative of sine is cosine. The second function is cosine. Well, what do you think derivative of it is? Well, it's actually minus sine. That minus people need to remember. Derivative of sine is plus cosine, but derivative of cosine is minus sine. Okay. The next function is exponential function, a to the power of t. The derivative of that is, again, a to the power of t times natural logarithm of a. Here, a is any positive number. Okay. So for example, a could be 2 or 3. So if we take an example, we're looking at 2 to the power of t, derivative of 2 to the power of t. It's 2 to the power of t times natural logarithm of 2. All right? And there's one important number, a, that often happens, often people see it in math. Okay? And that number is e. E is an irrational number. It's like a number pi. It's approximately 2.7, but if you're interested in the exact number, well, you will write it as e. Okay. It is also called Euler number, after Leonhard Euler. And the claim to fame of this number is simply that derivative of e to the power of t is actually e to the power of t. You take the second derivative of e to the power of t, again you get e power of t. So e to the power of t is actually, any derivative you take, it's a function itself. That's an interesting function. And we really get it from the formula above. If you know that natural logarithm of a, natural logarithm of e is 1. Okay? Since we start talking about logarithms, the question is, what is the derivative of natural logarithm of t? It turned out to be it's 1 over t. So it's t to the power of minus 1, and that's a power function. And you'll say, wait a second. We studied power functions, the derivatives of power functions before, and we found that if you want to integrate the power function, we're going to get power function back. And that's the formula we had, right? But logarithm doesn't look like this function, okay? So what's the deal? Are we having some problem somewhere? We have an error somewhere, mistake? Well, to see if we do, we just need to look at this guy. It's t to the power of minus 1. Now look at this formula and say, well, what's going to happen if I put n equals to minus 1? What's going to happen here? What's going to happen here is we're going to have t to the power of 0 divided by 0. Well, in math, we don't divide by 0. So basically, it tells you that this formula is not applicable when n equals to minus 1. In fact, this formula works for any n except for n equals to minus 1. And for n equals to minus 1, we need to use this formula.